Howdy folks, welcome back to another PE Genius exam practice problem for the Civil PE exam. Today we are looking at an eccentrically loaded wall footing. This problem is accessible on the PE Genius platform, www.pegenius.com, with lots and lots of other problems. Getting into it here, we have a wall footing at 3 foot depth, as illustrated here in the figure. Width of that footing is 5 foot. So it's a wall footing, so it's going in and out of the page. Keep that in mind. We have a concentric load of 12 kips per foot. That's every foot of the wall as you're going in and out of the page, you get 12 kips. Moment of 15 foot kips per foot, same deal, in and out of the page, 15 foot kips, right? It's asking us to find what the maximum soil pressure is. It's going to be at this corner over here. When dealing with an eccentric footing, you're really looking for two cases, right? First case is going to look something like this, where you've got this trapezoidal distribution. And really, what does that mean? That means that you have full bearing. That means your moment here is not too much. It's not overturning the footing so much that you've got this sort of uplift condition that you might see on the left side. It's not pushing it over too much. Another case would be it is pushing it over too much. And you got a distribution that looks like this in the red. Okay. Now what's happening here? That means you've got a high moment. Your footing is essentially overturning, so it wants to do this, right? It wants to lose contact with the soil on the left-hand side. It wants to really flip over, essentially. And you've got a high stress concentration, sort of distributed over not the full width, but partial width, okay? This all really is going to be dependent on how much eccentricity is on your footing. Eccentricity is really just a measure of how much we're overturning this footing versus how much we're weighing it down. That is to say, how much is our moment over our concentric vertical load here. Okay. We know the eccentricity is m over p intuitively, of course, because just looking at the units, we have 15 foot kip per foot over 12 kip per foot. The units are going to cancel out 2 foot. Eccentricity, of course, is measured in terms of feet. Okay. Or length, I should say. So we have 15 foot kips divided by foot, 12 kip foot. Okay. These are going to cancel out here. Kips are going to cancel out. You're going to end up with feet. We have 1.25. Oops. 1.25 feet. All right, there's our eccentricity. Now, what we need to look for is this eccentricity greater than b over 6? Or is that eccentricity, is the eccentricity less than b over 6, or is it greater than or equal to b over 6? Well, b over 6, if we look at what our b is, it's 5 feet. So sure enough, we are equal to the eccentricity. Now, what does that mean pictorially? Well, it means we are in the second case, but we're going from 0 in terms of our pressure at the left end to our maximum pressure at the right end. Now, as soon as you find this out, what you want to do, and I don't even have these equations memorized, so you want to head over to the reference handbook. I'm looking at handbook version 2.0. You might be looking at another version in the future, but if you're looking at version 2.0, head over to section, it's going to be 3.4.2.2. And in there, you're going to have particular equations used to find the maximum bearing pressure, whether or not, minimum bearing pressure for that matter, whether or not you are in full contact or in partial contact here, right? In our case, you'll find that the maximum bearing pressure is going to be equal to 4 times P divided by 3 times length L divided by the width B minus 2 times E. Okay. Now, going back and plugging in for all of our parameters, we've got 4 times that concentric load 12 times 3 times 1. Our length is 1 because we're considering each foot of the footing coming in and out of the page, right? And this is going to be typical when looking at wall footings. Our width is 5, and we got 2 times 1.25, okay? Now just solving up for this whole thing, we got 6,400 PSF, okay? And that's going to be the maximum pressure at this point over here per foot of footing as you're coming in out of the page. The answer here is A, of course. We've got more problems like this on the PE Genius platform, www.pegenius.com. If you have any questions or comments, please do leave them in the comment section below. And I do appreciate you subscribing and supporting our work here. Thanks so much.